All right, going on to page 56. Here we're going to do some subtraction of rational expressions. And we'll go over the technique in some detail to give you some background. Now, the general rule is when we are going to either add or subtract fractions, you must have a common denominator. So the first thing we do is think of, what would my common denominator be? Well, it has a common factor of w, so we'd have to have at least a w in there, which it already has. And then for I would say the answer, 6 and a 5, what's our common denominator? Well, one way to get a common denominator is just multiply these by each other and you get a 30. And that happens to be also the lowest common denominator. Now you do get a common denominator, but you don't necessarily get the lowest ones, especially if there are common factors within this. So now what we have to do is to modify this fraction, 5, 6w, so that its denominator is now a 30. Well, we're allowed to multiply anything by a 1. Let me write it over here. So 6w, I'm allowed to multiply this by a 1. It doesn't change its value. But the 1 I'm going to use to make this denominator equivalent to 30w is a 5. So I'm going to say this is 5 over 5. So now 6w times 5 is 30w, and then 5 times 5 is 25. And then we do the same thing here. We put the negative sign in there. We got to multiply this by what? In the form of a 1 to make it 30. And that would be 6 over 6. And usually we do this mentally. So this is going to be 24. And now we have it over a common denominator. And since these are like terms, we would just do the subtraction. And we get 1 over 30w. And that's the work supportive to get this answer. Now, if the denominator is already a common denominator, we just write our common denominator, and then this part, r plus 8. Now, we could change this to a plus here, put a parenthesis around that, and put the negative in front. That's okay to do. So now we have to change both of these signs. So this is a negative r and a plus 8. Now notice your r's subtract out. So we have a positive r and a negative r. So we then get 16 over 12. And now we can factor out a common 4. This would be 4, and then common 4 out of here is 3. So our answer after we do everything here is 4/3. Now, following the same protocol here, what will be our common denominator? Well, it would be the combination of this, 9y. Now we're allowed to multiply this by a 1. We want to make it a 9y. So we're going to multiply this by 9 over 9, which is a 1. So this becomes 45 over 9y, and this is a plus. And we want to make this 9 a 9y, so the 1 we're going to use is y over y. So this becomes a y here. Now that's our answer. I see the answer in the answer sheet is incorrect. This is the correct answer. So I've set up example 3 here. Again, what would our common denominator be? Because we're going to add these. Well, we just multiply them, and that's usually a good bet. And that happens to be the least common denominator. So again, we're allowed to multiply each of these by a 1. But we want to make these denominators this. So this one is missing a 1 in the form of x minus 7. And this one's missing a 1 in the form of x over x. So now we have our common denominator. So what will our numerator be? Well, this is going to be 3x minus 21, just distributing there, plus 6x. Now what we can do is combine like terms, so we get 9x minus 21 over x times x minus 7. Now you could distribute that and get x squared minus 7x. Oh, and then this will be 9x minus 21. But usually they want you to leave it in factored form, but they can't mark this one wrong. And this is how they are showing us in the answer key. All right, we'll clean this up and go on to the next. So our example is written out here. What would be our common denominator? Well, the only thing we need in the first fraction is a 3. So we're going to multiply this by a 1 in the form of 3 over 3. All right, so this then becomes a 15 plus 1. We didn't have to change anything here. So this simplifies to 16 over 3 times b plus 1. So again, they mixed a few more challenging ones with some relatively easy ones. Let's continue. And again, you can scan the video here, and I will give you my 2 cents in a sense. So what is the protocol when we have complex fractions? That is, a fraction in the numerator and a fraction in the denominator. Now there are a couple of ways to do this. I think the easiest is to do it this way. Put a parenthesis on the top and a parenthesis on the bottom. Now you're going to multiply both numerator and denominator by the lowest common denominator, which here happens to be a. Now I'm going to put the a there. It's not an exponent. It's just that I'm going to multiply both terms by this. And you'll see it gets rid of our denominators. So a times a is a to the second. Now here the a's cancel out, and you're just left with plus 1. Now here it's going to be a to the second. Here the a's cancel out, and it's going to be a negative 1. Now, I don't know if you see this. This is the sum of perfect squares. This is the difference of perfect squares. This would factor into its conjugates, a plus 1 times a minus 1, but nothing would cancel, so our answer is just this. Well, in example 1, we did it sort of an easy way. In example 2 now, this is a little more challenging. So another way to do it is to treat it as 2 different parts. The numerator as this, divided by this denominator, which is b over 1. So we're going to simplify this first. And we're going to add these, and I'll show you how to do that. So our common denominator here is a, and then a plus b, just multiplying these two together. So we're going to multiply this by a 1 in the form of a over a. And we're going to multiply this, and I'm going to make this a plus, and I'm going to put my negative there. And multiply this by a 1 in the form of a plus b over a plus b. Now I have here 9a minus 9a minus 9b. So this is what I have here. Now notice my 9a's will cancel out through subtraction, so I can just erase them here through the magic of an eraser. And I now have this to write the rest of it, but I'm going to change to multiplication and then flip this so it's 1 over b. Now I can cancel out my b's, and my final answer here is going to be a negative 9 over a times a plus b. So again, it looked a little complicated initially, but we're using the idea of combining this into a common fraction and then using the form a over b times or divided by c over d, that we then convert to a over b times, take the reciprocal of this, d over c. And this is what I've done here. But we had to get our addition of fractions first. All right, let's do letter or number 3 here. We can use our first method on this one. What is our common denominator here? Well, our common denominator is k. So if we multiply both of these by k, we should simplify our answer. So here the k's cancel out, and we get 1. Multiplying this by k, the k's cancel out, and this becomes a negative k squared. And multiplying this, we get k squared. Now, can you cancel out these k squares? No, because they're not factored. And remember, these are the difference of perfect squares, but nothing factors, so there's our answer. And looks pretty easy this way. So these are complex fractions, and we'll use the easy method in which we multiply both of our complex fractions by the common denominator, which happens to be a minus 3 here. So here we go, 3 times a is 3a. 3 times the negative 3 is negative 9. Now the nice part is now these cancel out and we're just left with a positive 9 there. Now 4 times a is 4a, and these cancel out here. I got to put my minus 12 here too. Wait a minute. Yes, again we're multiplying this 4 times the a and then the 4 times the negative 3. Now, when we multiply our next thing, these cancel out and we end up with a positive 12. Now notice here the negative 12 and positive 12 cancel out, so we can just erase that. And the negative 9 and the positive 9 cancel out. So for letter 4, this is our answer. It worked out pretty well there. So looking at example 5, we wonder what is our lowest common denominator here. And it's xy. So again, by multiplying this numerator by xy and this denominator by xy, the lowest common denominators of both, I'm going to get rid of my fractions. So here the x cancels with this x, and I get y squared. This x cancels with this x, and I get y times y is y squared. Now, this y, had a little cough there, let's see here. So this y will cancel with this y, and I get an x squared there. And now these just cancel out. And I'm left with x plus y. But notice now, this is the difference of perfect squares that will factor into its conjugates. Y plus x, no, we got to do y again. Y minus x, and this is over x plus y. Now, for all practical purposes, I could switch these around or these around. So these are common factors, and they would cancel out. And I'm left then as an answer for this, y minus x. I should clean that up a little bit there. And there we go. Okay, this is about 17 minutes, so we'll leave it at that. And I see they have a different answer, but I'm going to stick with this one.